You've probably had this experience. You buy a new power tool, drill, angle grinder, whatever, and it feels great for the first few weeks. Then something small happens. A drop, a bit of dust, a tough job, and suddenly the plastic housing cracks, the battery dies prematurely, or the motor burns out. Meanwhile, your grandfather's old manual drill or cast iron vise sits in the corner, rusty but perfectly functional after 50 years of abuse. It's easy to blame they don't make them like they used to, but that's not just nostalgia. There are real engineering reasons why many older tools and machines outperform their modern counterparts in longevity and reliability. Let's break it down. First, materials and over-engineering. Old tools, pre-1980s especially, were often made from thick cast iron, forged steel, or machined brass. They were heavy, yes, but that mass gave them rigidity and heat dissipation. A modern equivalent uses die-cast aluminum, thin stamped steel, or lots of plastic. The goal was cost reduction and weight savings. But thin materials fatigue faster, plastic becomes brittle over time, and lightweight designs flex under load. Second, simplicity of design. Older machines had fewer moving parts, no electronics, no fancy sensors. A manual lathe or milling machine from the 1940s to 60s had mechanical lead screws, hand wheels, and basic gears. No circuit boards to fail, no batteries to die, no software to glitch. If something wore out, you could usually fix it with basic tools. Modern equivalents pack in variable speed drives, LED lights, digital displays, Bluetooth connectivity. All of that adds complexity, and complexity is the enemy of reliability. One failed MOSFET or a shorted wire, and the whole tool is dead. Third, intended lifespan and repairability. In the past, tools were built to be repaired. Parts were standardized, screws were accessible, bearings could be replaced. Manufacturers expected you to keep the tool for life. Today, many tools are designed as throwaway. Sealed batteries, glued housings, proprietary parts. Repair costs more than buying new. Fourth, the good enough versus optimized philosophy. Old school engineers often overbuilt. They used bigger bearings, thicker shafts, more robust castings, just in case. Modern design uses finite element analysis and precise calculations to remove every gram of unnecessary material. It works great on paper until real-world abuse, dirt, vibration, or unexpected loads come into play. Then the safety margin disappears. A classic example, old bench vices versus modern ones. A 1950s Record or Wilton vise can weigh 30 to 40 kilograms and clamp almost anything without complaint. Modern budget vices are lighter, cheaper, and often break under half the load. The old one was over-engineered for worst-case scenarios. The new one is optimized for cost. Same with hand planes. A vintage Stanley or Record plane, properly tuned, can produce tissue-thin shavings for decades. Modern plastic-bodied planes feel flimsy and lose adjustment quickly. Of course, not everything old is better. Modern tools excel in precision, speed, cordless convenience, safety features, for example, kickback protection, and ergonomics. A modern cordless impact driver beats any manual brace in speed and power. But when it comes to raw durability and I need this to work no matter what, vintage often wins. The lesson isn't old equals good, new equals bad. It's about priorities. When manufacturers prioritize cost, weight, features, and planned obsolescence, durability suffers. When they prioritize longevity and real-world abuse, tools last generations. So the next time your expensive new gadget fails, remember, it's not necessarily they don't make them like they used to. It's that today they often choose not to. What do you think? Do you have an old tool that's still better than anything new? Or do you prefer modern features over longevity? Drop your thoughts in the comments. I read every single one. In the next video, we'll explore another everyday thing, how paper is actually made and why it's still irreplaceable in the digital age.